All right, how to find asymptotes using calculus. So rather than the college algebra tricks, let's verify all asymptotes using calculus. So we're going to use limits in this case. So first thing let's actually start off by looking at our function. And I'm going to do, let's say we do vertical asymptotes first. Okay, so how in the world are you going to find vertical asymptotes? The first thing that you always want to try to do would be to factor your function, if at all possible. Always the first thing. So in this case, we have a function that factors into x minus 1 times x plus 1, and then x plus 4 times x minus 3. Okay, so there's what we've got. We've got it completely factored. If something were to cancel, you would go ahead and cancel and simplify first. Vertical asymptotes, the trick is to first try to guess what they might be. So in order to do that, your best guess would be looking at the denominators there. What is it going to make that 0 on the denominator? That's going to make my entire function undefined. So that's going to be an x value that'll give me a vertical asymptote. So in this case, that's x equals -4 and 3. Okay, those are the first ones we're going to try. Start off with -4, and then you got to use calculus to verify that. Okay, so that's what we're going to go ahead and do. So if I want to start off with -4, you're going to start off by taking a limit, and let's say I want the limit as x approaches -4. And you have to pick a direction. It doesn't matter which direction you choose, from the left or from the right. One of them will suffice. It doesn't matter. Just one of them is enough. Of your function. So that's our goal, is we want to be able to take the limit of our function. So rather than writing f of x, let's actually go ahead and keep our factored version of the function. Just for simplicity's sake, it's going to make it, sorry about that, it's going to make that easier to calculate that limit. So you're thinking of a number that is close to -4, but on the right-hand side. So something that's close to -4, but on the right-hand side. Just in case you guys are curious one more time, really what we're looking at is if this is, let's say, a number line, and here's my -4, then a number on the right-hand side. So, for example, maybe -3.9. That's kind of the goal there. That's what you're really thinking about when you're thinking about what these numbers are. So let's say we're thinking about -3.9. And I'm going to go ahead and use that to plug that into my function. I can't actually plug in the number -4 because that's going to give me 0 on the bottom. However, I can think about, again, so this is my thought process, I'll write that over here on the side, of -3.9. This is not what we're plugging in. This is only what we're thinking about. Let's do that one thing at a time then. So let's say I looked right here at this factor right here. If I were to plug in -3.9, then that would become -3.9 minus 1, which is really -5-ish, give or take. So it's a negative number. It's not getting particularly large or small. So we're going to go ahead and turn that parentheses into simply some negative number. It's a -5-ish. Okay, and then we're going to do the same thing for each of the remaining factors. So for the next factor right here, for this x plus 1, plug in -3.9. Plus 1, you're going to get -3-ish. So again, a negative number. So negative number. And then you're going to see we're going to do that for all of the factors. So the next factor that we're going to be looking at then, this one right here, -3.9. Again, I'm thinking about -3.9. I could be thinking of -3.99, -3.99999. The idea of the limit is to just get closer and closer and closer to the x value in question, which in this case is -4. So we're thinking of -3.9. And if I were to do -3.9 plus 4, that is a positive 0.1. If I were to do -3.999 plus 4, that would be a positive number still, but even smaller. So it's going to stay a positive number, but it's going to get closer and closer and closer to 0. So it is definitely still a positive number. Let me give myself some space there. But it is a small number. Okay, and then last but not least, we're going to be looking at that last factor right here, -3.9 minus 3, and it's -7-ish, not particularly large or small, but it is a negative number. And then what you're going to realize is in this case, you have number on top, two numbers multiplied together, some number on top. But on the denominator, you're going to get incredibly smaller and smaller and smaller, closer and closer to 0. So some number divided by a super, super small number is an infinitely large number as we approach that limit. The only thing you have to then pay attention to is you're basically just going to be counting your negatives. I have 1 negative, 2 negatives, 3 negatives, and then a positive. okay? So 3 negatives, 2 of them are going to cancel, 1 of them is going to stay, okay? So for asymptotes, what we're really thinking about for these asymptotes is all I cared about is that I got infinity as an answer. So because I got infinity as an answer, that means that x equals -4 really is a vertical asymptote, okay? So let's go back and verify what it is that we were looking at the beginning. Here was our function. We were looking for all of our asymptotes here. Vertical asymptotes, we already realized that -4 worked, okay? So now what we need to do is we need to check the x value of 3. We're going to do the exact same thing, okay? So let's do that one more time. Well, that means we're going to have to take the limit as x approaches 3. And again, it doesn't matter which side you come from. I'm going to choose the right-hand side. It's not going to matter. You could choose the left-hand side. You only need to pick one of them, and you just have to get infinity as an answer was sort of your goal there. So I'm going to use the factored version of our function one more time. And I'm going to go ahead and see if I can calculate what this limit is. I'm going to think about what number do I want to think about here. I want to be close to 3, but on the right-hand side. So it's a number that's close to 3, but on the right-hand side, so maybe 3.1. So that's sort of our thought bubble over there. We're thinking about possibly 3.1. So as I calculate this, we're thinking about what numbers I could plug in. You're going to look at one factor at a time, okay? So the first factor I'm looking at is this guy right here. 3.1 minus 1 is about 2-ish. Not really large or small, so it's going to go ahead and just be some positive number. And then we'll do the next factor. So that's going to be the x plus 1. And in that case, we're thinking about 3.1 plus 1, which is about 4-ish. It is a positive number. And then again, we're thinking each factor at a time. So the next factor here that we're copying down was the x plus 4. Thinking about 3.1 or possibly 3.01 or 3.001 if you'd like. Plug that into the x plus 4 and you're going to get about 7-ish. Positive number is really all that was there. And then the last factor that we're looking at, again, this one right here, 3.1 minus 3. Well, that gives me a positive number, but it's a positive 0.1. So if I were to think about doing even closer, let's say 3.01. 3.01 minus 3. Still a positive number, but getting definitely smaller and smaller and smaller. And so a number, again, divided by a small number is infinitely large. You count your negatives. In this case, everything was positive, so I got positive infinity. Okay. So what that means is we can now conclude that I also have a vertical asymptote at the x value of 3. Okay. One more time. Let's go back and look what we were looking at the beginning. Oops, sorry. Here's our function. We found our vertical asymptotes. Turned out that both the x value of -4 and 3, those numbers will both give me a vertical asymptote. Okay. Last but not least then is we need to figure out how to find a horizontal asymptote. So for horizontal asymptotes, the trick is to not have to factor. So let's actually go ahead and do the horizontal asymptotes there. Okay, so horizontal. Okay, so for that one, your goal is still to look at a limit, okay? The limit that we're going to be doing now, though, is you're going to be taking the limit as x approaches plus or minus infinity. I'm going to start with the positive, and I'll do the negative later, of your function, okay? Just like we were doing before. And we're going to try to see what my answer is. Instead of writing out the function, the goal for horizontal asymptotes would be to looking at it before it was factored. It's just a little bit smoother. That's just kind of a trick for you guys. Just a bit easier that way. And now I'm going to have to do this limit at infinity, which is really, I've got a rational function. I can multiply top and bottom by 1 over the highest power of the bottom, and then simplify each thing along the way. I have not yet taken the limit, so I still have that limit notation there, okay? And then you're going to notice each one, basically I'm distributing across. So x squared, so the first one is x squared times 1 over x squared, and that's going to give you just the 1, minus, and then the 1 times the 1 over x squared is the 1 over x squared. And then on the denominator, same thing, x squared times 1 over x squared is going to give you 1. And then you're going to have to, in this case, it was a positive x times the 1 over x squared. So that'll give you a positive x over x squared, which simplifies to 1 over x. And then the negative 12 times 1 over x, which doesn't simplify into anything other than it stays there. Okay? And then you have to go through and actually calculate the limits now. So we're taking the limit as x goes to positive infinity. So you're thinking of a positive large number, like positive 500, okay? Or positive 5,000, or 5 million, or 5 billion. And you can continue to go as large as you can think of. So what's going to happen is the 1 is going to stay 1. There's nothing that's going to happen to that one. But over here, what's going to happen to this fraction? Think about it. 1 divided by a large number squared is going to get smaller and smaller and smaller. 1 divided by a large number is going to get smaller and smaller. 12 divided by a large number, smaller and smaller. So as those are going to get smaller and smaller, we ended up with 1 over 1, okay? And because you ended up with 1 over 1, you have a horizontal asymptote at y equals 1, okay? Horizontal asymptotes are y equals a number. Vertical asymptotes are x equals a number, okay? And just to clarify, where did we get those ones? That just came from those guys right there, copied straight over, because those are the ones that did not go to 0. Okay, all right, so just as a final sort of wrap up right there, you've got your horizontal asymptote of y equals 1. You are supposed to, for horizontal asymptotes, take the limit as x approaches negative infinity as well. Okay, in this example that didn't change anything because I ended up with now just a negative 0. It's really not going to make a difference. So you're going to get the exact same horizontal asymptote. Okay, but just keep that in mind when you're looking at horizontal and vertical asymptotes. Okay, so then in conclusion, you have one function, okay, f of x could be given to you factored, simplified, not factored. It could be given to you in any number of ways. Okay, and these are the things that we discovered. We found out it had some vertical asymptotes at x equals negative 4 and at x equals 3. It also had some horizontal asymptotes at y equals 1. Okay, so those are going to be those first clues as you go through and graph these. Okay, now if you're curious how to graph these, let's go ahead and get ourselves a good sketch of what this graph is going to look like. Okay, so let's go ahead and do that. Okay, so what we had is we had a function, vertical asymptotes. Those are going to be those vertical lines at the x values of negative 4 and at 3. So 1, 2, 3 here at negative 4. We'll draw some vertical asymptotes there, and then also here at positive 3. Draw some vertical asymptotes there. And then we also had a horizontal asymptote at the y value of 1. So here at the y value of 1. Okay. So that's going to be where our asymptotes are. And then we can also think about sketching the graph of what it's actually, the function's going to look like. And the best way to do that would be to use x and y intercepts. Okay. So in this case, if you were to look at the numerator of this function, if you were to look at that numerator and set it equal to 0, you're going to find your x-intercepts. Okay, and that's going to be my x-intercepts at positive and negative 1. Okay. And then the other thing that I think would be a great thing to be looking at as you're looking through graphing these guys is your actual answers to your limits. Let me go back to that first limit we found. The limit as x approaches negative 4 from the right-hand side. I got negative infinity. So negative 4 on the right-hand side. Here's negative 4. Here's negative 4. On the right-hand side, it's better shoot down to negative infinity. Okay, that's going to give you some hints there. All right, and what was it for x equals positive 3? Okay, so the limit as x approached 3 from the right-hand side, I got positive infinity. So here's my x equals 3. On the right-hand side, it shoots up to positive infinity. That's going to really help you get a good idea of what these graphs are going to look like. Okay. Other than that, I would recommend doing XY tables to get the rest of that kind of visual of what these graphs are going to look like. Okay? All right, so that is your lesson on horizontal and vertical asymptotes using calculus. So the important part was you had to use the limits to verify what your asymptotes were, and then you can get a good sketch. Ta-da!